So, other mode of transfer. So far we looked at free flight transfers, okay, and you can also achieve the stable transfer by dip. What do you mean by dip? So, you can also touch the droplet once it formed onto the pool, and when you pull it back, okay, so you also change the force balances. You can overcome the surface tension because the liquid pool surface tension would make sure that the droplet is detached, right. So, that kind of transfer is known as dip transfer or short circuiting transfer. Okay. So, this is a part of non free flight transfer. In free flight transfer, droplets are transported from the tip by free flight, is not it. So, you can also achieve the transfer by short circuiting. There are a lot of advantages having a short circuiting transfer. So, one of the major advantage is seen is controlling the heat input. So, we can also carefully manipulating by carefully manipulating the event of short circuiting, we can switch off the arc momentarily, okay, so that when the droplet is transferred, it is transferred by surface tension of the liquid, no other factor. By doing so, we can reduce the superheating of the pool. Okay. So, the one example schematic I show you here from post John Norris book. So, basically what we do is, so wire is continuously fed, is not it. If the melting rate is equal to the wire feed rate, what happened to the arc length? If a melting rate is equal to the wire feed rate, arc length becomes constant, is not it. But you can also carefully manipulate the feeding rate such a way that you slowly bring the wire towards the workpiece or well pool. Okay. So, increase the speed of wire feeding such a way that you can bring the workpiece or the filler to the workpiece and establish a short circuiting, right. It is clear. And once the short circuiting happens, and you also increase the current, is not it. And then what happens? So, once you have a short circuiting happens, you can also transfer the droplet to the workpiece. So, you form a droplet, and then once you are dipping it, you melt the droplet, and then subsequently you can pull the wire back. So, whatever is molten is detached by the surface tension of the well pool. Yes, it is clear. And in this process, the advantage is here, during these 3 steps arc is not there, is not it. So, when the moment the short circuiting happens, arc is gone, okay. And then you can dip the filler, okay. Either filler can melt before the short circuiting or during short circuiting it can melt, and then you can transfer the droplet by retracting the wire back. And during this process, by carefully manipulating the current voltage waveform, we can transfer the droplet without any explosion. So, that is very critical, because if you keep on passing the same amount of current, when you form a neck, then you increase the Lorentz force so high and you will have explosion. Okay. So, your power source should be capable of turning the current off the moment short circuiting happens, right. Okay. So, by deliberately keeping the wire fed slightly higher than the melting rate, we can establish short circuiting. The moment short circuiting is established, we will have to identify that moment and then switch off the current or reduce the current, okay. And then the molten droplet at the tip can be transferred to the workpiece by surface tension of the liquid pool, right. It is clear. I will show you a video, it will be very clear. So, you see the transfer. So, what is happening here? So, you have an arc. So, transfer happens by the short circuiting, and during the short circuiting event there is no arc. You see that? So, you establish the arc with an arc length, and then you switch off the arc the moment the short circuiting happens, and then you transfer the droplet by the surface tension of the liquid pool. Yes, it's clear?
So what is the explosion?
The explosion is the arc. Okay, so
It comes after the short circuit.
so we have this is a cycle. Okay, first is arc is struck. Okay. So this is the first event, the video is recorded. Yeah, so now a pulse. Okay, the droplet is molten. The tip formed a droplet, and then you are also pushing the wire because your feed rate is higher than the melting rate. Okay. And then the moment the short circuiting event happens, the power source switch off the current. Okay. So then we can the power source can measure the short circuiting event by measuring the voltage. Okay. When the moment the voltage becomes extremely small, that means that short circuiting has happened. Okay. And then the current is switched off, arc is completely gone. So now the wire can be retracted back, and during this process the surface tension of the pool pulls the droplet with its surface. Okay. So it goes back and droplet is transferred. You see that? And then the moment a critical length is achieved, arc is struck, ignited by the high frequency ignition, and this process continues. Yes. So you keep on doing it. So to achieve such a kind of complex metal transfer, the power source characteristics is extremely important, because power source would also calculate how much it melts. Yeah, melting rate should be calculated accordingly. Wire feed rate also be controlled, so that you can establish the short circuiting at a given defined interval. The moment short circuiting is established, again power source should measure the voltage of the system, and the moment the voltage becomes extremely small, current should be switched off, and then droplet can be detached by retracting the wire back. Okay. So what happens if you keep on passing the current? So then you will have an explosion. Okay. So if the current is passed continuously, so in this case suppose the equal amount of current is passed like an arcing current, and you have a very small area neck forming when you are retracting or when you are doing a short circuiting, and you have an enormous amount of Lorentz force concentrating on a very tiny neck. Okay. So if Lorentz force is concentrating on a tiny neck, obviously it will cause an explosion, right, because if you keep the current constant, the amount of Lorentz force is confined to a very tiny area. Okay. And the moment you constrain the Lorentz force, you have an explosion, because all the fundamental electrons are concentrating now on a very small neck. So that is the reason. So when you want to establish a short circuiting transfer, you need to make sure that the current is switched off. Look at the cross section area. Okay. It is decreasing extremely small, isn't it? You see that? So that is the reason. So if you want to achieve a proper short circuiting event, we will have to make sure that, so this is the current and voltage. The moment the current is, the short circuiting is happened, I will have to make sure that your current is also low, and then you can have a pulse to form arc and the droplet at the tip, and then you bring it down. So this is the arcing voltage, okay, and arcing current, and then the moment short circuiting is established, voltage becomes 0. So the current becomes minimum, right, and then you continuously again, so this is arcing voltage, and during this process you give a pulse, current pulse to melt the droplet and then bring it down. The moment the voltage becomes 0, short circuiting, minimize the arc, right. It is clear. So, this is how the controlled dip short circuiting transfer is established. So, this technology is very widely used nowadays in advanced GMAW process and various names. So, one of them is cold metal transfer. So, one of the technology advantage of here is, so the heat input can be reduced significantly, because when the droplet is transferred, technically you transfer it at the melting rate or melting point of the droplet, is not it, and arc is not continuously on, right. So, even in the pulsing transfer, the droplet is transferred in much higher temperature. Okay, when you are doing a free flight transfer, droplet temperature reaches to the arc temperature, or it is superheated, not arc temperature, it is superheated. So, the droplet is transferred in it as a superheated liquid in free flight transfer, whereas in the short circuiting transfer, when a droplet is transferred, we also switch off the current. So, when the droplet is transferred, you transfer it in a melting, close to a melting point of the droplet. Okay. So, the way you are dipping it, so the droplet temperature, melting temperature becomes more or less the same. So, that is why this process is also known as cold metal transfer, because the droplet temperature is much lower than in a conventional droplet transfer temperature. Yes, it is clear. So, this is known as controlled dip short circuiting transfer. We will see in subsequently in advanced GMAW process, when you look at end of this unit, what are the complex waveforms we use to achieve this transfer. But the basics is this. What is the basic? The moment short circuiting happens, voltage becomes 0, and the power source identifies that moment, switches off the current, and subsequently the wire is retracted. So, the forward and reverse motion of the wire is controlled by controlling the feeding rate. And how does the feeding rate is, how does feeding rate control? By calculating the melting rate. Okay. So, melting rate has to be calculated for a given diameter wire, for a given composition. So, then we can calculate the melting rate. Once you know the melting rate, and we know for a given arc length, when does short circuiting establish, right. It is clear. And these are all possible because of the microprocessor controlled power sources. The power source has a computer inside, a brain inside. Okay. So, all the programs are already preloaded while by establishing the entire process. So, if you give that is why we use in advanced power sources synergy. Okay. So, it is all synergistically controlled, the power source, because for a given composition filler diameter, the program is already there. So, what will be the feed rate? So, what would be the current it has to use for a pulsing, for a given pulsing, how much it is going to melt, okay. And if it is melting, how much feed rate it has to maintain, so that it can establish short circuiting and for a given time interval. Okay. We will see in some calculations when you are looking at in a pulse GMAW, how short circuiting at after one time short circuiting can be established. Okay, it is clear, right, the short circuiting transfer, how you do it. The trick is here is this is the trickiest part, controlling current and voltage. The voltage is controlled by itself because of this short circuiting. When the moment short circuiting happens, current should be minimized to avoid explosion. Yes, it is clear. Okay, we will move on. So, the some of the cases, and if you increase the current tremendously high, and if you also have a shielding gas generated, especially in self shielded electrodes, and you may also have an explosion transfer. Okay. So, most of the cases it happens in self shielded electrodes or in flux core arc welding electrodes, where you have a very high current, and if you are using it, and you have a gas which is actually generated by the flux, and the gas pressure is contained. So, you increase the plasma jet pressure and the Lorentz force, and you may expect an explosion of the droplet. And most of the cases it is extremely unwanted mode of transfer in any case, because you can never weld by exposure transfer. Okay. In most of the cases it is used for spraying or coating, and if you want to deposit FCAW wire onto the substrate, and you can use that, because anyway you do not care about where exactly droplet is going, right. So, you can do an exposure transfer by using high current, you can increase the productivity, but in GMAW it causes instability, because when you are doing welding you do not expect a droplet to explode and then go everywhere. Okay. You want the droplet to go to the well pool, the cavity. If you are using it in using the FCAW or any other electrode for deposit to make a layer, a coating, then you can we can use the exposure transfer. Okay, it's clear. Unfortunately, I don't have any video for this, because yeah, we never managed to get that. We need a very high current for exposure transfer. Good. So, if you increase sometimes the current, a jetting spray becomes rotating transfer. Okay, because again the reasons I told you the same. The jetting, if you start making a jet and you have a Lorentz force continuously forming, and then certain magnetic forces start rotating or changing the path of the spray, and you will have a rotating spray transfer, and it goes in everywhere. Okay, so and then you end up transferring the droplets at various places. Okay. So, again this is also sometimes used for surfacing, using an FCAW or in GMAW surfacing. So, again, so for welding applications it is not advisable, right. It's clear. Good. So, what are the most commonly observed transfer mechanism or transfer mode in various applications? So, as I said, for low current GMAW, globular, okay. And in CO2 cases, CO2 shielded GMAW, you see globular and repelled globular, okay, and because of the instability associated with the CO2. So, the GMAW above spray transition, it is the drop spray or projected spray, it is the same, and then once you increase the high current, then it becomes streaming and rotating and explosive transfer. An explosive transfer is very commonly observed in self shielding. What is self shielding? You do not give any extra shielding gas. Shielding gas is generated by the electrode itself. Okay, for example, we will go next slides. So, this is an MMAW, metal metal arc welding electrode, and you have flux on top of it. These burns generates carbon dioxide. Okay, so when you have calcium carbonate, when it burns, it becomes okay. So we generate shielding gas, okay, by burning flux. So this is used for the metal metal arc welding or shielded metal arc welding, and because of the CO2 generation and plus high current what you use to melt such a large diameter, and you sometimes get an explosive transfer. So, drop spray again just above or in and around the spray transition, which is the most advisable the transfer mode, drop spray or the projected spray. Okay, so on various transfers you would see. So, you can also achieve the short circuiting transfer by carefully playing around GMAW the parameters like wire feed rate, voltage, current. You can achieve this short transfer, and other modes you will see when we are looking at the mechanisms of SMAW and FCAW.